A company manufacturing washing soda had to specify the percentage of water of crystallization on its bottle. So what is the percentage of water of crystallization in this washing soda? Now, we are given the atomic masses of each of the elements. We have to find the percentage composition of the water of crystallization. So this is the entire washing soda. We have to find the percentage composition of this species. So how do we do that? We take the amount of this species by the total amount and we multiply it by 100 to calculate the percentage composition. So this is the percentage composition. That is the total weight of the particular species for which we have to calculate the percentage composition, that present in one molecule, divided by the gram molecular weight of the compound. And since we have to find the percentage composition, we multiply it by 100. So now let's calculate. We are given the formula of washing soda, which is Na2CO3.10H2O. This 10H2O is the water of crystallization which is present in the washing soda. So we are given that the relative atomic mass of oxygen is 16, sodium is 23, carbon is 12, and for hydrogen it's 1. So let's calculate first for the water of crystallization. We have H2O. The relative atomic mass of each hydrogen is 1. So we get 1 into 2. And relative atomic mass of each oxygen is 16. So we get 2 plus 16. And when we express the relative molecular mass in grams, that is known as the gram molecular mass. So gram molecular mass is abbreviated as GMM. So now we can express this in terms of grams. So we get 18 grams. But in washing soda, we have 10 molecules of water. So for one molecule, we have 18 grams. So for 10 molecules, we get 10 into 18, which is equal to 180 grams. This is the total amount of water of crystallization present in the washing soda. Now let's calculate the gram molecular mass of washing soda. Let's take this as 1. Let's take this as 2. So for washing soda, we have 2 atoms of sodium. So each has the relative atomic mass 23 multiplied with 2, plus each carbon has the relative atomic mass 1. Since there is only one carbon atom, each oxygen has 16 and there are 3. So let's first calculate for this Na2CO3. So we get this is equal to 46 plus 12 plus 16 3s are 48. So we get 16 and 10. And now when we add this to 10 H2O that we have already calculated, so we get 106 plus 180 for water of crystallization that we have already calculated, we get 286 gram. So we get the gram molecular mass of the entire water of crystallization equal to 180 grams. The gram molecular mass of washing soda equal to 286 grams. So the gram molecular weight or the gram molecular mass of 10 H2O, which is the entire amount of water of crystallization present in washing soda, it's 180 grams. And that of the washing soda itself is 286 grams. So now to calculate the percentage composition, we take the gram molecular weight of 10 molecules of water divided by the gram molecular weight of washing soda and we multiply it with 100. So we get on calculating 62.9%. So the percentage composition of the water of crystallization in washing soda is 62.9%. So this is the amount, or this is the value that should be present or written on the bottle of washing soda. Urea is a very important fertilizer for soil. This is also a very important fertilizer for many crops. This is because it has nitrogen, and nitrogen is very good and healthy for plants. So now, what is the percentage composition of nitrogen which is present in this fertilizer, that is urea? The formula of urea is CONH2 whole twice. And we are given the relative atomic masses of each of the species. So for oxygen, nitrogen, carbon and hydrogen, we are given the relative atomic masses. So now let's calculate the percentage composition of the entire nitrogen present in this urea. So this is urea. First let's calculate the amount of nitrogen which is present in this urea. So if you'll observe, since nothing is written here, this is 1. So we have 2 atoms of nitrogen in urea. Each nitrogen has a relative atomic mass of 14. So for nitrogen which is present, since we have 2 atoms, we get 14 into 2 AMU. And the gram molecular mass of nitrogen becomes 28 grams. So this is the entire amount of nitrogen which is present in urea. Now let's calculate the gram molecular mass of urea itself. So from the formula of urea, we know we have 1 atom of carbon, which is 12. We have 1 atom of oxygen. Then we have 2 atoms of nitrogen. And we have 2 into 2, 4 atoms of hydrogen. Each hydrogen has atomic mass of 1 and there are 4 hydrogen atoms. So now let's calculate. We get 12 plus 16 plus 28 plus 4. So this is equal to 12 plus 16. We get 28 plus 28 we get 56 plus 4 we get 60. So the gram molecular mass of the entire content of nitrogen present in urea is 28 grams and the gram molecular mass of urea itself is 60 grams. Now we have to calculate the percentage composition of nitrogen in urea. So what do? We have both the gram molecular masses. So we now divide the gram molecular mass of nitrogen by the gram molecular mass of urea, and to calculate the percentage composition we multiply it with 100. So what do we get? On calculating we get 46.67%. So this is how we get the percentage composition of the entire amount of nitrogen present in urea. So to calculate the percentage composition of any species, we calculate the gram molecular mass of that species in one molecule. We divide it by the gram molecular mass of the total compound and we multiply it by 100.